Hi teacher, I'm Cheng-Si, and I would like to say thank you to teacher because you always teach me in physics, and whenever I face some obstacles during my revision, Mr. Lee will always help me to solve the problems, and that's the reason why I get to score an A+ in my trial SPM.
Hello, I'm Richard from SMK Batu Lintang. I'm a Form 5 student and going to sit for SPM. I've joined Mr. Lee's physics classes since I was in Form 4. I would like to say thank you to Mr. Lee as he really helps me a lot in learning physics. He's a humorous and also friendly teacher. I like his teaching method as it is very interesting. At the same time, it is also easy for students to understand and also master the theory and concepts in physics. He also prepares a lot of real exam questions, such as questions from trial paper and past year SPM question, which helps students to master the concepts. Lastly, I would like to say thank you again to Mr. Lee for inspiring me in learning physics.
大家好，我的名字叫 Derek， 我是来自 SMK 巴顿丹的学生，今年读着 Form 5。首先，我要感谢 Mr. Lee 的教导，在 Physics 这个科目上，他是一名很棒的老师。我们遇到难题的话，他都会很有耐心的跟我们再讲解多一遍，让我们更加明白。我成功的提升我的 Physics 成绩，从一个 Grade C 上到了 Grade A， 所以我很感谢 Mr. Lee 这一年的教导。
My name is Esther and I'm from Singapore Private Secondary School. Thank you for Mr. Lee for his teaching and it really helped me a lot. 谢谢你细心的指导 Mr. Lee.
Hi teacher, I'm Cheng-Si, and
Alright, good evening. Good evening to all of you. Give me 1 minute. Alright. Welcome to my Physics Form 4 trial class. Form 4, I got 2 classes. One it is in Mandarin, the other one will be in English. Alright, Mandarin one will be on Tuesday, English one will be on Wednesday. And if you join, alright, you can join both. Alright, join my class, you can join both. You want to join Tuesday, you want to join Mandarin one, or you want to join the English one, yeah, up to you. And then if you want to watch replay anytime that you are free, you want to rewatch something that you like, I'm not sure about this one, I want to watch back, so you just click the link that I sent into the WhatsApp group if you join my tuition class. All right, and then for the student that you are interested for my tuition, all right, you can join my tuition class. All right, and I send the link of my Telegram group for you here if you are interested. Right, this is my Telegram group. Right, so inside here you can get the information. I send the link of my give me 1 minute. Okay, this is the form, all right, Google form. And yeah, if you tick this link, all right, and then you click this link, you come to here, you want to register, right? PTSC Tuition Center Physics Tuition Online, right? Registration form. All right, so let's say you put your email in already, let's say lah. Right, and then you can see valid email. Never mind lah. I don't, never mind. This is my email, right, at gmail.com. Okay, so you sign in your email, and then you want Form 4 or Form 5. This is Form 4, right? Okay, so you can have Tuesday, or Wednesday one. All right, you tick one. So if you want to have a trial class, do let the admin know. All right, they will help you. So after you register, I want to have a trial one. All right, they will let you know what you should do. Okay, so just create it and yeah. And then lastly, let's say lah, Wednesday, you want a Wednesday one. All right, so and then you submit your name, your phone, your parents, your birthday, and then referred by your friend. Who is your friend that asked you to join? You put their name. They can have 10 ringgit per month of deduction, right? And then you answer this lah. Term and condition, you read it, and then that's all. Okay. All right. Okay, now I introduce myself first. I am Mr. Lee. All right, and then I have teach physics for past 20 years. From 2004 my graduation, so I teach until now, right? 2024, right? 20 years already, June 20 years, right? So and then if you got any question that you want to ask, if you are my student, all right, you can PM me this number in WhatsApp. I can reply you very fast one. Like for example, you got question, teacher, I'm not sure about this one, or your homework you want to pass up, you can directly send it to this number, send it to me. All right, if you are not my student, you also can ask me question, but you cannot WhatsApp me lah. All right, not fair. So you can ask in this group, right? This group, right? Telegram group here. This Telegram group, if you want to join, you can join it right now. All right, this is my Telegram group, right? You can join it. And then this is the first thing that I want to tell you. The second thing that I want to tell you is about my notes. All right, so if you are my student, you are entitled to get the notes. All right, the notes I will send it into the Telegram group, right? Private Telegram group. Only you paid it, then you can get it. All right, the full notes will be from chapter 1 to here. From chapter 1 to chapter 6, full the notes. And then how to use the notes. Now I am telling you how to use the notes. Now you can see this is the notes here, chapter 1, 1.1, 1.2. All right, so here, what is best quantity? If you want to learn, hey teacher, I want to learn what is vector quantity. Okay, so what you do is you just click vector quantities. All right, so they will go to this part, vector quantity. All right, so if you go back to here, teacher, I want to not teacher lah, I want to learn what is scientific investigation. So you just click it, then you will go to page 16. That's how you use it. Very easy and simple, right? You no need to scroll down one by one, no need. All right, okay. Now if you got any friend want to join, do send them this link and then ask them whether you want to join or not. You want to join, you fill in the Google form. All right, thanks first before we continue. All right, so okay, so let's start our tuition today. So chapter 1, measurement. All right, so first of all, we are going to see what is called 1.1, what is called physical quantity. Physical quantity is something that can be measured, quantity that can be measured. All right, so what is something that can be measured, quantity that can be measured? For example, you got length here. Now this length, 3 cm, you can measure. This one 3 cm, 5 cm, 3 cm, 10 cm, right? You can measure, right? Quantity that can be measured, right? And for example, what else can be measured, right? For example, you are standing onto the weighing scale right here. This one is 5 kg, 50 kg, sorry, 50 kg. Oh, you can measure, right? What is your mass? All right, you can measure. Now, quantity that can be measured, it is called physical quantity. All right. Now, physical quantity can be divided into two quantity. Right. One of them are base quantity, so the other one will be derived quantity. So now we are going to focus into what is base quantity first. The definition of the base quantity you need to memorize, right? Whereas base quantity are the quantity that cannot define in other term of physical quantity. What is that mean? All right. So what does that mean? I will explain. Now, here that is 7 base quantity that you need to memorize, including their symbol, their unit. All right. You need to memorize it. Okay. Now, for example, we talk about base quantity first. We got 7 base quantity here, so you need to memorize. First one, it is length. Length. The symbol of the length is L. L. All right. And then the unit, it is meter. Now, of course, cm is the unit. Yes. All right. Cm is the unit. Km is the unit of length. Yes. But we are going to talk about this SI unit. All right. SI unit we are using, it is m only, meter. All right. Okay. Now, if this one is the base quantity, so only itself, meter only. You look at the unit, right? If you know how to use it, you look at the unit, right? So if we got area, it is length times length, which is meter, the unit of meter times meter. So the unit is meter square. So when you got something square or you got combination of other unit, so it is not called base quantity already. All right. So this is the 7 base quantity you need to memorize. Length, first one. Mass, all right. The symbol, it is m, and the unit, it is in kg. Time, t, in second. Temperature, big T, capital letter T, all right. Big K. This K stands for Kelvin. All right. This is second. This is kilogram. And then current. I, the symbol of current, it is I, and then the unit is ampere. Ampere. Luminous intensity, CD. What is CD? CD stands for candela. Candela. Okay, candela. And then amount of the substance, it is number of mole. How many mole? 2 mole, 3 mole, 5 mole. All right, mole. M-O-L-E. Mole. But the symbol, it is M-O-L. Okay, so these 7 base quantity, remember it. Remember it. Okay. Okay, so we got 7 base quantity already. Now, the next thing that we are going to see, it is derived quantity. Derived quantity. Okay, so we got 7 base quantity. So after you see the derived quantity, I'll come back to what is base quantity again. All right. So a derived quantity is a physical quantity, not base quantity. Right? It is quantity derived from the base quantity through the multiplication or dividing them. All right. So what does that mean? Okay. Now, first of all, we got area. Okay. Now I'm teaching you how to derive the unit. Also right here. Now here we got area. Area, like what I told you. Area is, the symbol is A. The symbol is A. The formula is L times L. L square. So L's unit, it is meter. Meter square. So meter times meter. Isn't it meter times meter? So this is base quantity. Yeah. This is also base quantity. So combination of more than one physical quantity, right? By multiplication or division. So that one, it is a derived quantity. So you look at the unit is meter square. So it is more than one unit already. More than one base quantity already. So more than one, we are going to call them as derived quantity. Okay? Derived quantity. Okay, now, so second one we are going to see volume. All right, so I'm teaching you how to derive the unit. All right, volume here. Volume it is equivalent to the second thing is you no need to copy my notes. No need, just leave it there. All right, why? So because after the lesson I will send a copy of my answer with complete notes with you, right, to you into the group, so you no need to worry about notes. Right, volume. Volume, the symbol it is L times 3. Right? L times L times L. So you see, this is the unit of meter times the unit of meter times the unit of meter. So the unit is meter cube. So this is got cube already. Meter times meter times meter. Multiplication. So this is derived quantity. Alright. So next one, density. So density. Density, if you learn it before, right, it is mass over volume. So mass, the unit, it is in kg. Right. This one is best quantity. Mass, it is best quantity here. Here, mass, the unit is in kg. Right. Volume, just now we just learned it. Meter cube. Meter cube. Meter cube. So when you write this kind of unit, right, how are you going to write it? So you are going to write it as kg. If over it is negative, or you minus it. The power, you minus the power. Minus 3. Right? Sorry. kg m minus 3. Right? So it is kg m minus 3. Right? kg m to the power of negative 3. I always I get used to write call it as minus 3 kg m minus 3. So I seldom call it as kg meter per meter per meter per meter. So the correct way to call it is kg kilogram per meter per meter per meter. Alright, so long. Right? Or sometimes I'll call it as like kg m to the power of negative 3. I will call it that way. I will put it that way. Okay, that is density. So now, of course, the thing that you ask me is, teacher, how do I know the formula? If I don't know the formula, I don't know the velocity, I don't know the acceleration, I don't know the density formula, how? Is it given in SPM? Yes. SPM, this formula is given. Alright, I can show you there. How to derive the unit here. So how to derive the unit? Alright, this formula is given in SPM. Alright, so I put it, attach it into page 13. So for example, you want density, you need to find it here. Density, the symbol is rho. This one is called rho. Density is equal to mass over volume. Mass over volume. For example, you want others, all the unit it is here, all the formula it is here, right? Given in SPM 60 something formula, right? Including the constant, some number, some important number that you need to know, right? Okay, come back to here. Now, basically, you know what is derived quantity already, alright? Later, we are going to see one by one. Now, come back to here. Teacher, I still don't understand what is best quantity. Okay, so what is best quantity? Best quantity is cannot define in other term of physical quantity. Cannot combine mass and time, current and time, current and temperature. Cannot time them, cannot divide them. So just leave it alone, right? So just leave the time alone. Right, you look at the unit is second only. You look at the unit is Kelvin only. You look at the unit is ampere only. Right? Of course, if you talk about length, so this length got big categories, right? This length including the width, the height, the distance, the displacement, all of these are categorized under length. As long as how long it is you can measure, it is called length. I don't care whether it is distant or not. So if you ask me, teacher, distance is best of derived quantity. You look at the unit distance, distance, if you go there, how many meter? Or 5 km. Alright, so just this k, it is not the unit. This is called prefix. So 5 km is 1 only. So it is best quantity, right? 5 cm best quantity, right? If you talk about the volume is 5 meter square, right? 5 meter cube, sorry, 5 meter cube. So you see meter times meter times meter. So this one, it is derived quantity. You look at the unit, then you will know. Okay, I think it is quite easy for you to identify them. Okay, cannot define in other physical quantity, other term of physical quantity. So it is best. So derived quantity is you combination, right? You time them or divide them. Okay, so just now we talk about density. So now we talk about what is velocity. So velocity is, the formula is displacement divided by time. Of course, what is displacement? You are going to learn later. So it is the unit, it is in meter. It is one kind of length. It is one kind of length, right? Over the time taken. Time taken, the unit is in second. So meter divided by second. Velocity is kind of like speed, right? So the unit is meter divided by second. So we call it as meter per second. ms minus 1, right? ms minus 1. ms minus 1. So the unit is ms minus 1. So the way to derive it, we are going to do it later. Okay, so now I just tell you roughly what is this and how to do it later. We are going to do it later. Okay, now we understand what is best quantity, we understand what is derived quantity already. Now we are going to see physical quantity also can be categorized under what is scalar quantity, what is vector quantity. We got two kind of quantity, scalar quantity and vector quantity. So what is scalar quantity? Scalar quantity is the quantity that has magnitude only, right? So magnitude only, no direction. So this one with magnitude only but no direction. This one no direction. So if vector quantity are the physical quantity has the both magnitude and direction. Okay, magnitude and direction. Now, how to identify them? All right. So here, teacher, what is magnitude? All right. Of course, you ask me, teacher, I don't understand what's magnitude. All right. So let's say you got 5 meter. 5 meter, the 5, the number, it is magnitude. You got the magnitude, you got number. All right. So for example, 20 meter, 20 degrees Celsius. Okay. 20 degrees Celsius, the 20, it is magnitude, got number 1, right? For example, negative 10, all right? Negative 10 degree Kelvin. So the negative 10, it is a number, magnitude. You got magnitude, right? So the direction normally go left or right. So you will see whether the thing it is go left or go to the right. Okay. Right now, give me 1 minute. Okay. Okay, got magnitude only, no direction. For example, it is distance, right? One of it is distance. Okay, distance. So if we are going to identify what is vector and scalar in detail. So let me finish what is vector first. Vector quantity are the physical quantity has the both magnitude and direction. This one got magnitude only, but this one got magnitude and also got direction, right? So what is mean by magnitude and direction? Let me explain to you what is distance and displacement, right? So now you are here. So you try to work forward, jalan 10 meter, and then come back 3 meter. You stop at here. You move 10 meter and then come back, return 3 meter. So you finally stop here. So what is the distance? Distance, because of it is no direction, only magnitude. So you just plus it. You just plus them. 10 plus 3. 10 plus 3. So answer is 13 meter. Now, same thing. If I ask you what is the displacement, how much is the displacement when you work from here to stop at here? Alright. So displacement, you only see where do I start and where do I stop. So I start from here, right? And then I end at here, right? So another word, you are moving from here to here. Moving from here to here. Here to here. Oh, okay. So from here to here, we are going to call it as 7 meters. So the displacement is 10 minus 3. You have 10 here minus 3. Why minus 3? If you minus 3 mean you got direction. You got left and right. Okay? So you got direction. So it is 7 meters. So the difference is distance don't have direction. You just press it. Displacement got direction. Whereas you need to plus or you need to minus it. Okay? Now, scalar quantity, no direction, no direction. Okay? So distance and displacement. Now, of course, if this kind of question if you go to chapter 2, I am going to teach you in more detail. Whereas you come to here and then come to here. This is 10 meter. This is 15 meter. Right? The distance is, you start to jalan from here, you work from here, and then you are walking all the way here, and then you finally stop at here. Right? So the distance is 10 plus 15. It is 25 meter. Alright, 25 meter. And if displacement, so you can call it as 10 minus 15. 10 minus 15. So you got negative 5 meter. Normally, I said normally, not 100%. Right? Normally, go left, it is negative. Go to the right, it is positive. Another word, when you start to move from here and then you end at here, so your displacement is from here to here. So got direction. This negative telling you are moving to the left with 5 meter. Right? If I tell you you move 25, I know total distance you move is 25, but I don't know you move to the left or right. So displacement, I got direction. I know you move to the left or you have moved to the right finally. Right? That's the difference between distance and displacement. Scalar quantity and vector quantity. Okay, you don't need to copy, just listen. Okay, the next example is speed and velocity. Right? Speed, it is a scalar quantity because speed don't have direction. Vector quantity, example, it is one of the example, it is velocity. Velocity has direction. Okay, so we try to have a look at what is speed. Speed is distance divided by time. Okay, distance divided by time. And here, velocity, it is displacement divided by time. Right? Distance divided by time and displacement divided by time. Alright, so what's the difference between distance divided by time and displacement divided by time? Like what I told you just now. Right? So if you are moving 10 meter, right, you return 3 meter in 5 seconds. Okay, so we find what is the speed? Speed. What is the speed? Right, speed is 10 plus 3. Right, distance is 10 plus 3. Over the time, how long time it take? How long time it take? It takes 5 seconds. 13 divided by 5. 2.6. The unit, alright, so the unit is very, very important. 2.6 unit is, this one is meter. The unit it is in meter. Right? This one, the unit it is in second. Right? Meter divided by second. Meter divided by second. ms minus 1. Okay? Meter meter per second. Alright? Now, so we are going to see what is velocity. Velocity is here. Where do you start and where do you stop? So from here to here. Right? 10 minus 3. 10 minus 3 over 5. The time both are using 5 seconds. Same. 5 seconds. So 7 divided by 5. So you got your direction, you got your velocity 1.4. That's different, right? So this one got direction, right? Why got direction? Because of it is displacement, right? Because of velocity is displacement divided by time. Okay. So hopefully you understand what is speed, what is velocity, yeah. And then next one. Next one, it is time. Right? This one is time. And then time, temperature. So others, I want you to memorize. So time go to the left or right? No, don't have. Temperature. Now, temperature is left or right? Don't have. So temperature, it is a scalar quantity. Area is left or right? No. Volume? No. Density? No direction. Density, the formula is mass over volume. No direction. You memorize it. Mass, no direction. Work done, no direction. Work done or energy refer to the same thing. This is most of the students they get wrong here. Right? I tell you why it is wrong. I tell you what's wrong and why it is wrong. Okay. Now, acceleration, got direction. Momentum, got direction. If you ask me what is momentum, what is impulse, you are going to learn in future, not today. Right? Later, we are going to derive the unit, but what is the meaning of momentum and impulse? You are going to learn in future. Alright? Weight and force. Alright? Weight and mass are two different things. Right? Mass, no direction. Weight, got direction. Weight, the unit that you normally use is in Newton, right? And then force. Force got direction. Force you push to the left or right. Got. Right? Weight, it is going downward. Weight, it is always going downward because of gravity. Okay? Now work done. Okay. Now work done, the formula of work done is force times displacement. Right? Force got direction? Yes. Vector. Displacement, the unit, the symbol, it is S. Normally we are going to use S. Displacement. Got direction? Yes. But work done, no direction. Right? The different thing. Yeah, force got direction, displacement got direction. But work done don't have direction. Or energy don't have direction. Is that okay? I hope you're okay here. I go faster. Now we try to do some questions from here. Physical quantity is a... What is physical quantity? Quantity cannot derive in other term of best quantity? No. Quantity that contain a magnetic and direction? No. Quantity cannot be measured? No. Quantity can be measured? Yeah, that one is called physical quantity. Right? Quantity that can be measured. You can measure what is that, how much it is. Right? Now, which quantity is a best quantity? All right. So best quantity got 7. All right. Wait as I ask you to memorize. It is length, time, temperature, mass, electric current, number of mole, amount of substance, and luminous intensity. All right, that's 5. So what is among that 5? Among that 7, sorry. Among that 7, so it is electric current. Electric current. Alright? Which of the following is not a scalar? Mean I want vector. Vector, weight. So where, vector, weight. Yeah, here. Weight. Okay. Time, it is no direction. Temperature, no direction. Right? Energy, I told you, energy or work done don't have direction. Now this one is kind of hard because of the question, right? Is Newton per meter square, right? So Newton m -2, it is, what is the unit? So this one, if you learn in future, you will know what is this. But I give you the answer first. The answer is, this one is pressure, force over area. The force over area is your pressure, right? Force over area. Force, the unit that you use is Newton, but Newton, it is not SI unit. Newton is the unit we use, but Newton is not SI unit. Newton, area is meter square, so that you got Newton per meter square. This one, we're going to write it as Newton per meter square, and this one, we are going to call it as Pascal. Pascal is a person name. Newton is also person name, right? Pascal. Pascal. If you go to Shell station to pump your car tires, so you ting, you pump the car pressure, car tires pressure, so you find it, oh, that one is 2000 Pascal, 200 Pascal, 1000 Pascal. All right, so that one is Pascal. No, that one is kilopascal. All right, kilopascal means bigger lah, time 30 at the back. So answer is Pascal. Pascal. Okay. Now, which physical quantity has the correct SI unit? Correct SI unit. So now, quantity of matter, mole, yeah. Temperature, it is not degrees Celsius, it is in Kelvin. This one must be in Kelvin. Right? This one is big K. Right? Mass, it is in kg, not gram. Time, it is in second, not hour. Okay? So, meaning that A is correct. A is correct. A is correct. Next one. Density is a derived quantity. Density is derived quantity. The quantity can be derived as, so what is density? So density is, the symbol of density is, density is rho. This one we call it as rho, rho. Rho is equal to mass over volume. Rho is equal to mass over volume. Density is equal to mass over volume. Right? Density is equal to mass over volume. Density is mass over volume. So mass, what is the unit? What is the unit that we use? Right? Mass, it is in kg. Right? Mass, the unit, it is in kg. Volume is meter times meter times meter. Meter cube. Meter cube. Right? So now this one kg, this one meter cube, right? Kg is this mass, okay? So volume, meter, length times length times length, it is meter cube. Yeah, correct. Right? Volume. Length times length times length. It is volume. So answer is A. Okay, number 7. Which of the quantity is vector quantity? Vector quantity is the one that has direction. On both magnitude and direction has direction. So which one has direction? Acceleration, yes. Energy, no direction. Mass, left or right, no direction. Distance don't have direction. So answer is A. Alright, the notes here we got it here. Vector quantity. Now, one of the example is acceleration. Okay. Next one. Which of the following it is correct? Which of the following is correct? Scalar quantity. Scalar quantity, no direction. Vector has direction. But in your definition, when they ask you in structural question, you cannot say, oh, scalar is a quantity that has no direction. No. You must say has magnitude but no direction. Or has magnitude only. Mean don't have direction. You must put it into proper word. Okay. Scalar quantity, this one momentum got direction. No. This one salah. Force got direction. Salah. Mass, yeah, correct. Mass no direction. Time also correct. No direction. So left C and D. So density. Density is mass over volume, which is no direction. Displacement got direction. Yes. Vector got direction. Yes. So answer is D. Right? Density don't have direction. Now we are going to try to do some question here. Which of the following is to measure the vector quantity? Alright, so we understand what is this. This is a stopwatch. Stopwatch, you measure the time. Okay, so this one measure the time. Time, it is not vector, it is scalar. Okay, so this one, what is this? This is this is ammeter. Ammeter is to measure the current. Right, electric current. So current also the best quantity. Alright, so this one is, you look at this unit, this unit, it is Newton. So this machine, it is called spring balance. So spring balance used for what? To measure the weight of the object, weight. Right? Not mass, weight. What is this? This is called triple beam balance. Triple beam balance. What's the use? Triple beam balance is used to measure mass. To measure mass. To measure the mass of the object. Right? Like you put that up there, 5 kg. Alright. You know, oh, this one 5 kg, 20 gram, 10 gram. Okay, you know. Right? Triple beam balance. So which one is vector quantity? Only weight. Vector quantity from the knots here, knots here. Vector, weight. Okay, vector, weight. Other or scalar. Okay. We continue. Which one is the best quantity? So best quantity is the potential difference? No. Electric current? Yes. Potential difference and electric current, two different things, but they are related. Resistance? No. Power? No. You need to memorize this one. No choice. Now, which of the following it is imperial unit? Okay, let's understand what is imperial unit first. Right? So I'm going to teach you what is imperial unit. Imperial unit, it is used in the okay. Imperial unit, it is used in measuring normally the all system of England, right, UK, they are using this, right? Inch, right? Feet, how many feet? 2 feet, 3 feet, how many inch? 2 inch, 3 inch. So we use this kind of unit. So this kind of unit, it is called imperial unit. So it is imperial measurement system. All right. So from England one, right? From UK last time, right? But we normally use like cm, length. We use cm. We use meter. All right. but some of them they use inch and feet, right? For example, you look at this ruler. I got this ruler. So this one at here, I don't know whether you can see it or not. This one, you can see it here. This is a ruler, so they got the length of inch, how many feet. Use this, right? So like for example, the football star, LeBron James, how many feet? 7 feet. No, 5, 6 feet. How many? 6 feet at inch. They are using this. They are using this. Now it is equivalent to, let's say lah, I'm not sure because I don't use it. So it is equivalent to like 200 cm or 2 meter, like that. We use 2 meter, right? Okay. Or in, like for example, football. Some of them they play football. When they play football, they are using how many yard? 30 yard. 12 yard penalty. Yard. Yard is one of the imperial unit. Okay, imperial unit. So which of the following is imperial unit? So inch, yes. More, no, this is best quantity. It is not. Meter, no. SI unit, this is called SI unit. Candela, CD is SI unit. Okay, SI unit. Next one. Which of the followings are all derived quantity? Derived quantity. Alright, so derived quantity including force, yes. Time, no. This one salah. Time, wrong. Momentum, yes. Alright. Momentum, yes. Force, yes. Velocity, yes. Alright. So all are direct quantity, yes. If you ask me, teacher, why momentum, you know it. Alright. Force, you know it. Vector. So other than that 7 best quantity, that is all derived quantity. Other than that 5, it is called the derived quantity. Other than that 7 best quantity is called derived quantity. Next one. This one is all syllabus, right? Before 2021, it is all syllabus, but never mind, I put it here. I put it here for your extra knowledge. They will ask you what is sensitive, right? So what is sensitive? Sensitive is your ability of the instrument to measure to detect the small changes. Even very small, you also can change it. You also can detect it. So this one's the smallest one you can measure is 0.5. This one's smallest one is half of the 0.5. So this one you can measure 0.25. Okay, so this one is you measure here, it is 0.1, 1.0. Alright, kg, this one is all kg. So this one, the smallest thing that you can measure, it is here, it is 0.5. You need to divide by 1, 2, 3, 4. Right, 0.5 divided by 4, 1.25, 0.125. So this one is 0.125 kg. So which one can measure the smallest one? This one is 0.5, smallest one. So which one is more sensitive? This one, because you can detect small changes. Very, very small, you also can measure. Alright. Now come to do some question that looks something harder. Okay. Now diagram 1 show Auni stand at O. So he worked toward B and go to A again. He go to B and then go to A again. He go 7 and then go 9. Alright. Now what is the displacement? Displacement is 7 minus 9. It is -2. But no -2, then we take it as +2. Right? Meaning that here, you work to here, it is 2 meter. Alright, 2 meter. Next one. Which of the following is not the best quantity? Not the best quantity, I want derived quantity. Second best quantity. Candela is luminous intensity, right? Brightness one, right? So it is best quantity. Centimeter, meter baru, right? Meter. Centimeter no. Centimeter no. Number of mole, yes, right? It is best quantity. So centimeter is not. Next one, which pair it is correct? Okay, so the weight and vector quantity, yeah, correct. Weight is vector quantity. Distance is scalar quantity, not vector. Velocity, it is vector quantity, right? Acceleration, it is vector quantity. So A is correct. Next one, inch is the example of imperial unit. Just now I told you imperial unit, not SI unit. Okay, now we look at some structural questions. Diagram 1 shows a graph of displacement time against two racing cars on a straight track. Initially, the car racing A, it is starting at the line, and B, it is 15 meters ahead. So I got two cars. One, it is 15 meters ahead, right? So from the other one. So now car A, it is from here. B, it is from here. Alright. So now displacement is best or direct quantity, they are asking you. Displacement, it is best quantity or direct quantity. Displacement, it is under the categories of length. Length, meter only. You look at the unit meter. Meter is best quantity. Now meter, it is best quantity. Next one. What happened to the racing car A and B at the 10 second? At the 10 second, A and B, they meet together. Alright. Racing car A and B meet together at 10 seconds. Alright. Now calculate the velocity. Velocity, how to calculate? Alright, so here velocity of B. B is velocity is equivalent to your displacement over the time. Displacement divided by time. Displacement here is from 15 move to 20. Initially it is 15, finally at 20. So 15 to 20. So 15, 20 minus 15. So you got 20 minus 15. Over the time taken, it is 10 seconds. So 5 divided by 10, you got 0.5. You got 0.5. Unit is meter per second. Meter per second. Okay. This is all kind of question that related to heat, alright, 2021. So I'm gonna skip this one. So I'm not going to do this one. Not going to do this one. Okay. Now we try to have a look into this one. Now diagram 1 shows a consumer need to undergo a body temperature check before entering the business premise with the COVID-19 outbreak strikes. So complete the following sentence by ticking the correct box in the definition. Temperature. Temperature, it is a degree of hotness. You need to know, need to memorize. In chapter 4, I'll teach you. Right, from 4, chapter 4. So what is form of energy? Heat. Heat is a form of energy. Heat is a form of energy. Temperature is degree of hotness. Temperature is degree of hotness. Now, state the type of the physical quantity. State the type of the physical quantity measured by the thermometer. So answer is physical quantity is temperature. So you don't call it as degrees Celsius. No, that one is unit. No. Okay, that one is unit. No. State the unit of represent in diagram 1. Right? What is the unit represent temperature? So answer is Kelvin. Big K. Kelvin. Set the unit Kelvin. So you can write it as Kelvin or K. One of it will be okay. Just one of it will be okay. Okay. Now, what is the temperature reading from the diagram SI unit here? So what is the temperature? You read from here. This is 36.6. But this one, 36.6, the one that we measured, it is in degrees Celsius. How to change the degrees Celsius? So degree change to Kelvin. So you need Kelvin. You need to plus 273. Plus 273. This 273, it is called absolute temperature. Right? You need to plus 273. If you change Kelvin to degrees Celsius, so you need to minus 273. So now we are having 36.6 degrees Celsius. I want to change to SI unit. SI unit is Kelvin. So you need to plus 273. So it is, answer is 36.6 plus 273. 36.6 plus 273 is is 309.6. 309.6 unit Kelvin. Okay. This one, in the future, you, chapter 4, now I just tell you first. Chapter 4. You learn in more detail how to convert the unit or all this. Okay. Now, come back to how to derive the unit. Right? How to derive the unit. The formula of this one is given in SPM. It is given, right? You don't need to worry. So, how to derive the unit? Okay, we are going to try one by one. All right, I want to make the unit. So first one, I want area. Area. The symbol is this A. Area. It is length times length. Right? Length times length. Length times length. Right? Mean I want to find the area of something here. Let's say 5 cm, 10 cm. Okay, should be 5 cm, 10 cm. So area is, this is length, this is width, this is length. So now 5 times 10, 5 times 10. So it is 50 cm times cm square. You got this unit. So length times length. The unit is length times length. The unit is. So now I want to derive the unit, right? So the unit is length is meter. Length is meter. So answer is meter square. Right? Equal to meter square. Meter square. Okay, it is equivalent to meter square. Okay, now the next one is, we got volume B. B, volume. Volume, how to get the volume? Wait. Volume. Normally we are going to use big V for volume. So volume, the formula will be length times length times length. Right? So volume, volume length times length times length. This one you have learned it in lower form already. Length times length times length. So I straight away give you the unit. So length, it is in meter. Meter times meter times meter. So meter cube. Meter cube. Okay. C. Now C, velocity. Velocity. Velocity is the formula, it is equivalent to displacement divided by time. Displacement divided by time. Displacement divided by time. Displacement is, unit is in meter. Time, it is in second. Displacement is best quantity. Alright. Time, it is best quantity. These two combination is derived quantity. Meter per second. So meter divided by second, we are using the symbol, the unit of ms minus 1. ms negative 1. So the unit used for the velocity, it is meter per second. ms minus 1. Okay, see? Now D. So what is D? D is called acceleration. So what is acceleration? Acceleration, we're gonna use A. The formula is V minus U divided by T. Right? Where to get it? Alright. So it is actually come from here. Right here. The first formula. Alright, I built the formula for you. This is given. V is equal to U plus AT. If you want to find A, this U you move to here become minus. V minus U is equal to A times T. Now T go away because I want to find A. So V minus U and then divided by T. V minus U over T is my A. A is V minus U over T. That's how the formula comes from. That's how it comes from. So now A is V minus U over T. Now be very, very careful when you do this. Is when you minus, the unit must be the same. Minus will not change the unit of V and a teacher. This V and this U, the unit you minus no more. No. So what does that mean? Now, for example, I got Rm5 minus Rm2 left Rm3. Your Rm still have after minus. Rm4 divided by Rm2 is 2. No unit already. Divide, cancel. Divide and time, you will change the unit, but minus will not change the unit. Right? Minus the unit still here. So when you see the minus, you use the V's unit. V's unit is here. Yeah. The V unit is here. So the up there, it is ms minus 1. Is equal to ms minus 1. Over one more s. Right? Time, it is in second. Time, it is in second. ms minus 1 minus 1 again. So ms negative 2. You got the unit of ms negative 2. ms negative 2. Right, you got ms negative 2. Is that okay? Okay. D. Now, after D, we got F. F is force. E. F is force. Force. The formula force F is equal to MA. 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 Right? F is MA. F is MA. Now here. F is MA. Equation number 6 here. MA. M. Do you have M? M is mass, right? The unit is mass is in kg. A we just do it ms negative 2. So you got ms negative 2. ms negative 2. So the unit is kg ms negative 2. kg ms negative 2 is the force unit. But we normally use this one force. The unit that we use is not this one. We want it to be easy, we use N. N stands for Newton. Right? 2 Newton, 3 Newton. It is actually SI unit is kg ms negative 2. Right? But we use Newton normally lah. E. Momentum. Now we are going to make momentum F. Momentum. Momentum got one symbol, it is P. Small p. But we seldom use it. Including the formula given in SPM. Momentum, you see, momentum they get you momentum is m times v. M times v. They don't use the p. So m times v. So momentum equivalent to m times v. M times v. So what is m? M is mass. What is v? Velocity. So we have both. Mass is in kg. Velocity is, we have just do it here. Here, velocity. So here it is ms negative 1. ms negative 1. So momentum's unit, you got it already. kg ms negative 1. Right? Kg ms negative 1. So it is a direct quantity. Right? So F, we got G, density. G. Density, the formula, it is given as mass over volume. Density, it is mass over volume. Okay. Density is mass over volume. Mass, what is the unit? Kg. Volume, the unit? Volume, the unit, it is meter cube. So kgm minus 3. You got kg m negative 3. Right? Why negative 3? Because of it is at the bottom. Right? So you got kg m negative 3. Right? m3. Yeah. Okay, this one, the unit is in mass, kg, volume is m3. So kg divided by meter cube. So it is kg m negative 3. kg m minus 3. So G, H, we look at what is pressure. H. Pressure, we are going to use the symbol of P. Right? P. Pressure, the formula is force over area. Force over area. Here, pressure, the formula is pressure is equal to force over area. Right? Pressure is force over area. Now, pressure is equal to force over area. So, force, the unit here, we got it here, force, the unit. Right? Force, the unit is kg ms negative 2. So, you got kg ms negative 2. kg ms negative 2. Area is meter square. Alright, kg ms negative 2 divided by meter square. So you see 1m can cancel, 1m can cancel, left bottom 1m. Bottom 1m, we said m is negative 1. So kg m negative 1 s negative 2. M negative 1 s negative 2. Right? M negative 1 s negative 2. Alright. Now H I energy. Energy is equals to, symbol is E. E is equals to E, energy is equals to force times displacement, F times S. This formula you have learned in Form 3, whereas you never learn it. It is not given in SPM formula, right? Force times displacement. Force, we got it here. Force, here, kg ms negative 2. Displacement. So, kg ms negative 2 time one more s it is in meter, so meter times meter here, meter times meter, so we got meter square. So the answer will be kg m square s negative 2. So you see, m times m become m square. S negative 2 just follow. Kg still remain. So this is my answer. Energy. Okay. Now lastly, it is power. Right? J, power. So power is equivalent to, power is equals to, now the formula is power is equals to work done divided by time, or energy divided by time. Here you can find this one, power is energy divided by time, or work done divided by time. Energy is work done. Work done is same as the energy. Alright. So energy divided by time, or work done divided by time, as I told you. So now work done is energy. Alright. Kg m square s negative 2. You got the unit of kg s. Kg m square. M square s negative 2. Right? Time divided by time. This one energy over the time. Time it is in second. Time it is in second. So I cancel one, not cancel. So this one is negative 2, and then you minus one more. So you will get kg m negative 2 KGM -2, KGM2, sorry. KGM2, and then -2 minus 1 again. So you got -3. You got -3 as -3. You got this. Okay, you got this. Any question from here? Any question from here? Alright, if no, we go a bit of what is prefix today. Alright. If I finish this prefix, then I will end the class already. So prefix. Next week we baru go for scientific investigation. Okay. Now, what is prefix? This prefix, you are not going to learn it in our syllabus here, but it is good for you to learn and know and memorize it. So prefix is something that can use a short form to represent the number, right? For example, you got T, big T, G, M, K, D. So this T stands for tera, giga, mega, kilo, density, centi, milli, micro, nano, pico. So this one, tera, stands for 10 to the power 12. 10 to the power 12. Giga, 10 to the 9. Mega, 10 to the 6. Like micro is 10 to the -6. So what is 10 to the 12? Mean you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 0 at the back of that number. What is micro? Micro -6. -6 means you got 1, 2, 3, 4, 5, 6. You have to move negative. You have to move 6 decimal forward. Okay. Now, how to memorize it? Okay. The green Monster King. The green Monster King drink chocolate milk making night party. The green Monster King minum susu. Hijau punya susu. The green Monster King drink chocolate milk. Drink chocolate not mean hijau punya susu. The Monster King is green, but the chocolate is not green. I'm sorry. The green Monster King drink chocolate milk making night party. And what you need to memorize is from 12. 9, you minus 3, minus 3, minus 3. After you minus 3, 0 cannot. So, cannot. Leave it. So, it is -1, then -2, -3. After 3, then you minus 3 again. Minus 3, 6, 9, 12. That's how you minus. That's how you memorize. Okay, you see how I memorize? Without seeing it, so you know it is the green Monster King drink chocolate milk making night party. So from 12, 9, 6, 3. So -1, -2, -3. And then lastly, -6, -9, -12. That's how you memorize it. That's how I memorize it. And what is the use, right? For example, in your daily life, right? For example, you got symbol and unit use, right? So for example, you got GB, right? So my hard disk 500 GB rosak. I want to go buy the hard disk for 500 GB. This G, it is a prefix. This B, it is a unit. The unit. So this unit is gigabyte. Giga is how many 0? Byte is a memory. Byte. Memory of the hard disk. So meaning that if you don't use the prefix in daily life, you need to go to the shopkeeper there and ask him, I want to buy 500 000 000 000 byte punya hard disk. The boss will tell you, again, can you repeat? 500 000 so hard lah. So why not you just tell me 500 gigabyte? Oh, okay. Or 0.5 terabyte. Oh, okay, I know. the number make us easier. Okay, in daily life. Make the number easier, make our life easier. So how to convert the unit a prefix into the SI unit? So for example, 300 km, how am I going to do it? 300 km is 300 kilometer, which is equivalent to 300. Kilo, it is here, kilo, times 10 to the 3, times 10 to the power 3. Unit meter. SI unit for length, it is meter. Yeah, that's all. But we normally put the answer in standard form. When standard form, the front number here cannot more than 10. It is cannot less than 1, cannot more than 10. So now you move 2 decimal. How to move it? Okay, you move forward, this number becomes smaller, right? 300, you move 2 decimal, 1, 2, right? Become 3. It must be 1 in between 1 to 10. Time 10. This number move 2, so move 2 forward, this one becomes smaller, become 3, right? This number becomes smaller, this number have to become bigger. Bigger mean you have to plus. Plus how many decimal you move? Plus 2. So just now it is 3, then you 3 plus 2. So answer is 3 times 10 to the 5. Unit meter. So this unit, so I don't want. I want it to be 3 times 10 to the power of 5. The front, I repeat, the front here, this front here, 300 become 3, become smaller. At the back have to become bigger. Move 2 decimal mean tambah 2. Move 3 decimal mean plus 3. That's all. B. So 20 millisecond. 20 millisecond is equivalent to 20 millisecond is 20 milli. Milli is times 10 to the negative 3. Milli times 10 to the negative 3. Right? 20 millisecond. Now second is the unit. No need to worry. And then this is 20. I said it must be 1 to 10. So this one move 1 decimal, become 2. 2. So this number becomes smaller already. From 20 become 2, become smaller. So this number had to become bigger. Bigger mean plus. Right? Plus 1 decimal. Plus 1, negative 3 plus 1 become negative 2. Unit second. Any question you want to ask? You can ask if you don't know. Okay, next one. 0.2 microampere. Zero 0.2 microampere, it is equivalent to 0.2 micro is times 10 to the negative 6 times 10 to the power negative 6. Okay, times 10 to the negative 6 ampere. Now this one is 0.2. It cannot less than 1, I told you. So this one become 2, become bigger. So become bigger mean at the back have to become smaller. Alright, times 10 to the smaller mean minus 1. Alright, because you move 1 decimal. So here you have to plus minus 1. So negative 6 minus 1, it is negative 7. Negative 7. Unit, it is ampere. Leave it ampere. Yeah, correct. So 12 gigagram. I want to change to kg. Right, this one slightly harder. If you want to change to other, because the SI unit is kg, right? You need to change it to SI unit. Right? You don't want to change it to gram. You want to change it to SI unit. So 12 gigabyte. Gigagram. Sorry. Gigagram. Sorry. Girlfriend pula. So It is 12 times 10 to the 9 gram. So you want to change it to kg. If you change to other type of kg, you minus. Right? 12 times 10 to the 9 minus the new prefix minus the new is kg. So minus times 10 the k is 3 minus 3. Then the kg write down. I will explain to you why. Okay, so 12 times 10 to the 9 minus 3 is 12 times 10 to the power 6 kg. Whereas this one is 12. No, I said cannot be 12. So you need to change it to 12 become 1.2. So the front becomes smaller and the back have to become bigger. Bigger is mean plus 1 times 10.7 kg. Okay, times 10.7 kg. Alright, now I explain to you why. You see, this one 12 giga. 12 giga, huh? 1, 2, 3, 4, 5, 6, 7, 8, 9 gram. Right? 12 gigagram. Kilo is this 3. Right? Kilo is this 3, yeah? So, now this one is kilogram. So, left this one, write down. So, this 3, 6, 6, 0, 1, 2, 3, 4, 5, 6, and then you got 12. So, move the decimal 1, 2, 3, 4, 5, 6, 7. So 1.2 times 10.7. The prefix is writing this way. The prefix is doing this way. Yeah? Now, here, I will give this one as your homework. This one is your homework. So, if you want, you can try to do it this one. We are going to discuss next week. Next week, we are going to start to do the scientific investigation already. And if you're watching, now the two link there is one of it. It is my Telegram group. It is free. Right? You got many information there. You can ask question there. It is free. And then if you want to join free, so I give Form 4 2 lessons for free one. So which is last this week and next week. Right? Free one. So after that, if you are happy, you can click the link to join my tuition. And if you join, you will get the notes here. Right? The notes I'll give you. Right? The notes only when you join. Right? And my tuition will be 2 hours. Right? Normal time will be 7:30 to 9:30. 7:30 to 9:30. Normally 7:15 to 7:20 like that to 9:30. And then I am this year I am going to do kind of fast a bit. Why? Because this year your exam SPM from this year from 5 SPM will be earlier. So your time will be adjust back. So you need to rush, right? We need to rush. No choice. That's why I will need to start earlier, slightly earlier. And then Form 4 foundation is very important to determine your Form 5 can get A or not. Lastly, if you join only, you ask your friend to join, you got 10 ringgit rebate per month, every month, right? Your friend write your name. Please write the referral as your name. You got rebate every month, 10 ringgit. Meaning that if the tuition fee is 65, not if, the tuition fee is 65. After March, will be increased to 75. Be fast to join. So after you join, you ask 7 friends to join. So you can get free tuition and you still get earn money. Ask your friend to join now. Alright. I am going to stop here. I am Mr. Lee, and together we learn. We are going to see you again. I will see you again. Alright. Thank you for the lesson. So we are going to see you again. I am going to see you again, not we. Alright, bye bye. 少了。
上了2个小时的课，大家都辛苦了，谢谢你们有专心上课，下个星期一样时间。